Hi all, Dr. Clark here again. For forest management, this lecture we're going to talk about tree height or calculating tree height. I touched on this a few lectures ago with basically stating more information to come. And here's that more information. So I'm going to talk about one major method in calculating tree height, and I would argue that it's probably the most common method because of the cost of equipment and whatnot. So there are two technical ways of calculating tree height. One is using a clinometer. The other one uses a hysometer. Hysometer, it does all the work for you. Okay? And I would argue if you're going to do tree height for a living and you're working for the Forest Service, you'll probably just use a hysometer. Okay? I show you in the video that's coming. I show you myself using one. It calculates the tree height for you. Okay, a clinometer is what someone would use if you're kind of a hobbyist, or maybe you've actually used the similar method in maybe a math class. If you had someone that was teaching you geometry or trig or something like that, they might have had you take tree heights just to get you out of the classroom, kind of thing. So we're going to talk a little bit about the method that has mathematics involved with it, because it's a method that you can practice. The hypsometer, you're not going to practice because it basically just spits out what the tree height is. The clinometer, you need to do a little math. So we're going to progress with do the little math method. Okay, so first of all, the ultimate goal is to get the height of the tree from the base where it's touching the ground to the crown of the tree or the tip of the tree branches. Okay? Now, again, like I said before, sometimes the tip, it's meaningless because you're not going to do anything with the tip of the tree. Maybe much further down, maybe at the 60% mark, maybe that's actually usable board foot or usable tree, and maybe that's what you need to know. But at least knowing to the tip of the tree, you know, well, okay, so I know if I cut the tree off at 2 foot, okay, I know exactly how much is going to fall in a certain direction. That might be important to know if you're going to be, cutting trees down in a neighborhood or in a region that might have objects. So it is still important to know all the way to the tip, even if you're going to be working on broadleaf trees or deciduous trees. It's still important to know because you got to fall that tree. So you got to know where it's going to lay. All right, so the ultimate goal is to know the height of the tree. Now, you'll see in the video that I show, when the video that's coming, that shows me actually using a clinometer to get the height of the tree. I tell you that I purposely walked out a certain distance, okay, until the degrees to the tree was 0. What I mean by that is this angle of your eye to the base of the tree. So I walked down slope, to a point where my eye was even with the base of the tree, which gives me a 0-degree angle, which means the only angle I'm worried about is the angle of A1, or to the crown of the tree. So I only have to worry about 1. Now, if you are downslope, upslope, or for that matter, on a level slope, and the angle to the base of the tree is not 0, you have to do a little math. If you're below that angle, you're going to have to subtract how far, or the distance that your eye is below the trunk of the tree. Okay, so you're going to have to subtract A2, or the height of A2, that triangle, from H1. Okay, so that's what that is showing you here in this figure, is H is actually equal to H1 minus H2, on a downhill slope if you're looking up to the trunk. Okay? If you're on an uphill slope, okay, and you're looking down to the trunk, it'd be h1 plus h2, and I'll show you a diagram of this in a second. Okay? So again, the ultimate goal is to just get the height of the tree, and sometimes you have to calculate, well, the height of you or the height that you're looking at, and either account for that in some way, either by adding to the height of the tree or subtracting the height of the tree. Okay, so very simple equation. The height of the tree is equal to the distance you are from the tree times the tangent of the angle to the tip of the tree. Okay. In this case, you have two h's, h1 and h2. So you have to do those, and then you can make that simple math. Okay, so let's look at another example. One that probably was, if you've done this before, this is probably an example that was given to you similar to this, okay? And that would be the exact same equation, but you're adjusting for the height of the individual. So basically what's being stated here is you have a distance from the trunk of the tree. Okay, you will need to move away from the trunk of the tree until you can visualize the crown of the tree. Okay, so there will be a certain distance you have to get away from the tree before you can actually see the tip of the tree. And for most clinometers, they only allow you to look at somewhere around a 49 degrees angle. Okay, so you'll have to take that into account, the equipment that you're using. Okay, so you can see here this little man standing on his head, because that would make this equation correct. The height is equal to the tangent of A times D. Okay, so just a simple triangle calculation that'll give you the tangent of A times D will give you H. Okay? But in most cases, you're not going to be standing on your head while you're looking through a clinometer. So instead, what we often will do is we'll say the tangent of A times D plus the height of the eye, or the height of your head. Okay, and if you're standing, that's one height. If you're kneeling, it's another height. You know, whatever your eye height was, okay, you have to add that in. Okay, well, that's fine if the ground is completely level. In most cases, the ground's not completely level, so it's actually better to get your degree, like the first picture showed you, the degree to the trunk, okay, and the degree to the crown, and then calculate the two, add them together, and I'll show you that right here. Okay, so a couple different ways to do this, couple different adjustments that you must know. So if you are on a hill, the upside of a hill, and you're looking at a tree in the valley, you need to create two triangles and add them together. So you'll get two heights and you'll add them together. So you'll get the tangent of triangle 1, which would be from basically your eye level to the crown. You're going to take that measurement, okay? And then you're going to get a tangent angle from your eye level to the base of the tree, and you're going to get that measurement. You add them together, to get the height. Pretty simple, but it's important to know that you must calculate or adjust based on where you are on the landscape. Okay, let's say you're opposite. So now you're downhill, the tree is uphill from you. Now you're looking up at the tree, but in actuality, you have two angles again, two triangles. One from the base of the tree up, okay, and one from the base of the tree to your eye level. So two triangles, so you now have to calculate for that extra area that you're going to be examining. So in this case, you would actually subtract off that extra material from your eye to the ground level or your eye to ground zero. Okay, you subtract that off so you can just get the height measurement. Okay, and then again, if you're on level land and you're looking at the base of the tree, then you can just get that one triangle and add the height to your eye, or the height to the piece of equipment. So a lot of people use a clinometer on an actual tripod or something like that, so they'll know the distance from the ground to the clinometer on the tripod, and that would be that height that you would be adding to the system. Where it gets complicated and interesting for people who enjoy math is when you have trees that are not quite vertical and they're more leaning. Okay, you need to account for the lean. So often you will have a triangle that is made off the crown of the tree, the crown of the lean of the tree, and that'll give you one height. And then you have a height for whatever, either your eye height or your tripod height. Okay? But then you also need to calculate another triangle that takes into account the angle of the tree, the distance the tree leans over, and then you're going to have to calculate for that. Okay? It's fairly simple to do as long as you know what you're doing. You would just take the height at the point of the crown, the lean of the crown, add that to the height of your equipment or your eye. Okay, so in this case, 11.7 meters. Okay, and then the distance of the lean needs to be accounted for. Okay, and you stick it in to kind of a simple equation where it's 11.7 squared plus 5 squared. So you're squaring both the height and the distance of the lean. So you get two triangles coming off this. Okay? Then you're going to take the square root of that, and that will give you the height of the tree, accounting for the lean. Okay? We're not going to mess with this maybe as like a bonus question or extra credit kind of question that might be thrown in there, because it's a lot more advanced mathematics. For some of you, it'd take you a long ways back to trig, and some of you may have never taken trig. But for these, pretty simple. You just got to remember that you need to account for where you are at on the landscape. Okay? So let's look at the clinometer. Okay? The clinometer is an interesting piece of equipment. Okay? Now, obviously, if you're a forest manager, or you're going to do this for a living, a clinometer is an old piece of equipment. Okay, you'd rather use a hypsometer, or even you'd rather use a rangefinder, which is going to use a similar technique of like a laser guiding system to find out the height of the tree. Okay, and if you're really technical, you're not even going to find the height of the tree. You're going to use an airplane that flies over the forest, shoots lasers down. They bounce off of all the objects. They come back up. Now, the amount or time that they traveled down, okay, and came back up, some of them are going to hit the ground, come back up. Some of them are going to hit the crown of the tree, come back up. Okay, and then you'll know that the time differences, and the computer does the calculation for you, and it tells you the entire height of every tree along the flight path of that airplane or that helicopter or whatever flying device is used. I'm not sure if they use drones yet, but I could easily see this piece of equipment attached to a drone and used in a drone system too. Now, for those of us who don't have hundreds of thousands of dollars to buy very expensive equipment, and are okay with doing a little mathematics, the clinometer works perfect for that. Okay? So there are two ways to read the clinometer. You need to be familiar with both because I will present data on both. Okay, so the clinometer has two reading points, and so you can see over here in this scale here, this is what it looks like inside the eyepiece of the clinometer. It'll show you degrees. Okay, so that's that alpha that I was talking about, the degree of the angle that you're looking at from 0 degrees, which is level, to, whatever it might be, the crown of the tree might be, is going to be a different degree. And then the other side is percent. So the percent will actually have to do with the percent of the distance of the tree that you are from the tree. Okay, so basically a good clinometer that has both degrees and percents is actually really just automatically going to calculate that tree height for you. The degrees is going to be a little more mathematics, but it works along the same lines as the percent. It's just you're doing a little more math. So that being said, percent much easier. Okay, so if I say the clinometer reading is 50%, the distance to the tree that you walked away from the trunk of the tree is 38 meters. All you need to do is take 50 divided by 100 times 38, and that gives you 19 meters. Okay? Now, again, if I say that you took a reading at 50 degrees, okay, then I have to tell you basically what the height of the individual was. If the height of the individual is 1.6 meters, you have to add that 1.6 meters to the 19 meters, because I'm not telling you that you're not on level ground or anything like that. So that information is all there. Let's look at another one, but not using percent. Instead, we're going to use degrees. So let's say the clinometer reading is 35 degrees and the distance of the tree is still 38 meters. So the height of the tree is a little more, you have to calculate it a little different. So you take your 38 meters, you're going to times that by the tangent of 35 degrees. So in this case, you'd have 26.6 meters. You still are 1.6 meter high. Okay, or at least this individual is. The height to the eye is 1.6 meters. Add those, you get 28.2 meters. Okay, so in general, it's not a super difficult calculation, but know how to calculate the height of the tree using percent from a clinometer and the height of a tree using degree from a clinometer. Okay, all right. The next piece of the video is really just showing you how basically a demonstration of how I take it, like a tree height measurement. You can see me in the field, and then this information should give you enough information that you can complete the tree height assignment. Okay, till next time.
Hi all, Dr. Clark here, and this video, or these video clips, are going to be clips of me doing different techniques like aging trees, looking at tree height, DBH, canopy cover, those kind of things we talked about in lecture. I'm in northeastern Arizona and in a region that burnt in 2002. One of the largest wildfires in the history of Arizona State, called the Rodeo Fire, burnt here in 2002, and you can see that a lot of it hasn't come back yet. Now there are a few trees, like these ponderosa pines, that made it through the fire, and we're going to look at the age of these trees. And then obviously there's some other things like some juniper that made it through, but the majority of the trees and whatnot perished, and 12 years later You have some yucca or soap tree yucca plants coming back. You have rabbit brush coming back that are fairly large. You have some antelope brush that came back. But again, you know, 18 years later, and the landscape is clearly, you can see that it's scarred by a fire. So it takes a while in some regions. It takes a while for things to come back. That's not to say that they won't come back, but it can take a very long time. So I'm going to go through how to do different things, like take the height of these trees using a hypsometer and a clinometer. I'll use them both, and I'll show you how to use both of them. I'm going to take the DBHs using a DBH tape. That's the only piece of equipment I have. I don't have DBH calipers because I don't use them. And I don't have a Biltmore stick either because I don't use those either. But again, if I get my hands on one, I'll repost a video showing you how to use them. And then I'm going to use a GRS. Okay, so GRS, hypsometer, clinometer, DBH tape, and then a tree core. I'm going to use that GRS to get the canopy cover of, you know, some regions throughout the forest, and I'll show you this. Okay, all this data that I collect will eventually go into spreadsheets, and then you as students or whatnot will get to run the numbers, crunch the numbers as assignments, those kind of things. I just keep that data because that's what I do. Anyhow, I think I'll start with the height of the trees, and I'll show you how that's done in just a second. Hi all, I'm back. Okay, so the first tree that I'm going to take the height measurement of, and I'll show you how that's done, is this tree right here. Okay, so kind of the middle tree right in front of me, and I'll show you the height of that tree. Okay, and to do that, I'm going to do it two ways. Okay, I'm going to use a hypsometer, which will tell me the distance I need to be from the tree. Okay, and then I'm going to use a clinometer, which basically I get to pick the distance I am from the tree. Okay, now I walk to the tree, and I'm at the base of the tree. Now I'm going to walk a known distance away from the tree. So I already measured this out. Okay, I measured it out to 40 feet. Some people carry like a big tape measure with them into the field, but most people who do this work for a living, they just know how many steps it is to get to 30 feet, 40 feet, or really they know how many steps they take to make 10 feet. So I'm at 40 feet, okay, and I can take out my clinometer, and you can see on the back of the clinometer, okay, you can see that it already does the tangent of the different degrees for me. Okay, so we're working with this equation down here. Okay, we're interested in y. Y is equal to x times the tangent of the angle that's made between x and basically the angle at which you're looking at the top of the tree. Okay, and so we're interested in what the tangent of that is, and that table will tell me that. So what the clinometer does is it allows me to look through here, and while looking through here, I can move it to the top of the tree, and it will tell me the degree of the angle, or the degree of the angle that I'm looking at to the top of that tree. So with one eye I'm looking through, with the other eye I'm looking to the top of the tree. Okay, I look to the top of the tree and I get 39 degrees. So if I look at the back of this and I look at 39 degrees, okay, the tangent of 39 degrees is 0.810. So now all I have to do is the simple math. Okay, I know I am 40 feet away. That is X. And I'm going to times that by the tangent of the angle that I just calculated, 39 degrees. The tangent of that is 0.810. And when I do that in my calculator, I get 32.4 feet. Right. So the clinometer is telling me that that tree is 31.4 feet. Okay, pretty legit, I guess. Okay, so let's see what the hypsometer tells me. Hypsometer is a little bit different. Okay, it works on the same way, but it's faster in the sense that it will tell me exactly what it is without doing the math. It does the math for me, basically. Okay, so again, I'm going to look through this. I'm going to click it. It's going to tell me the distance I need to be at is 10 meters. Well, I know 10 meters is about 30 feet, so I'm actually going to move forward to another mark that I made at 30 feet. Okay, and now I'm going to click it again, and it will ask me for the degrees that I am away from the base of the tree. Okay, so it's calculating whether I'm on a slope, downhill, etc. On the clinometer, you need to do that yourself. It just happens to be that I moved away 40 feet until I got to a clinometer of 0 degrees. So I was perfectly even with the base of the tree. In this case, at 30 feet or 10 meters, okay, I am looking at a negative 4.7 degree angle to the base of the tree. Okay, after I've set that, now it asks me to go to the height of the tree. Okay, so I'm going to move up till I get to the crown, the tip of the tree. I'm going to click it, and it's going to tell me what the tree height is. In this case, it tells me in meters, but it doesn't really matter. I can make that conversion. Okay, it says it is 11.1 meters. Okay, so we know that there's, roughly 3 feet per meter. Okay, so times 11.1 by 3, it says it's 33 or so feet. Okay, so that's pretty close. 32.4 and 33. Those numbers are pretty close. So the height is, somewhere in that ballpark of, 30 plus feet, plus a couple feet. Okay. Now, you might say, well, it's more accurate to climb the tree. Indeed it is. I mean, I could climb that tree and drop a rope or a measurement or something like that and tell the exact measure of the tree. But really, is it going to make a difference for 1 foot? Probably not, because you're not even going to use the crown of the tree for board foot. So that's why people like to use clinometers or hypsometers, is because they're much quicker. Okay, you can go in, boom, boom, get your 2 measurements, move to the next one, walk 40 feet away, whatever, take your measurements, pull out your calculator, and you're done. You're not putting on gear, you're not climbing a tree. It's much faster and still very reliable. That's, a 30-foot tree. Okay? All right, so when we come back, I think I'm going to pull out the DBH tape and show you how to take a diameter at breast height.